And hey everybody, Mr. Stewart here. Welcome back to the fourth part in this series at Math We've Got This. We're representing equations with algebra tiles, and we are solving equations using a balance model, a balance tool. So I'm just realizing that carrying on from part 3, we've got a lot of tiles up here. So before we actually use the balance tool, I'm just going to bring that into place. Before we actually use this thing, I think it would be wise for us to maybe simplify first. Okay, and what I mean by that is you'll notice on this side of the equation, we've got a lot of zero pairs. In fact, we do have quite a number of them. Let me see if I can actually cover them all here at a time. No, it's not going to. Okay, so let's do this one at a time. So let's just zero out a few of these. And that's going to make life a lot easier for us. So in fact, we have these 8 unit tiles that we need to be dealing with or working with, that is. Okay, so what we're going to do is now use our balance tool to help solve this equation. So let's bring down the 3x minus 12. And I'm just going to draw these unit tiles a little closer together to make it easier to work with the balance tool. Okay, so there we go. And then we're going to bring down the right-hand side, or the expression for that. And let's see if I can grab, well, I can grab the zeros too. I don't think it really matters because, I mean, 0 is 0. But just so it's not as confusing in its look, let's just grab each of these tiles one on their own. Super exciting stuff here. Okay, we'll get to the good stuff in just a sec. There we go. Okay, now let's balance this equation out. Now we're ready to use the tool to solve this accordingly. So let's just, I'm going to clear this whole space out. Let's just make this nice and tidy. Great thing about PolyPad is you can do this very quickly, moving all this stuff around. So let's see what we can do here. These two negative x tiles, why don't we create zero pairs out of those so that we can end up bringing all of these x tiles to the left-hand side of our equation. There, that keeps it balanced. So now we need to remove all of these negative tiles. So that means we need to create a bunch of zero pairs. In fact, why don't we look for this many? 1, 2, 3, 8 zero pairs. So let's do that. Let's zero out 8 of these. Okay, so there's 4 so far. 5, 6, 7, and 8. Okay. So we zeroed all of those out. Now, because we added 8 tiles to the left, we need to do that to the right-hand side. So let's duplicate that. Okay, and I'm just going to move this around a little bit to make some space. Okay, so far so good. Now the last thing is we still have these 4 tiles here on the left-hand side. So we do need to remove those. So let's do that. Let's bring in and create more zero pairs. So we'll create 1, 2, 3, and 4 more zero pairs. And to keep things balanced, what we do to one side, we must do to the other. And why don't we just duplicate this? That'll make it nice and quick for us. And there we go. It's all balanced out. Now the last thing to do is to find out just exactly how much x is equal to. So notice that we do have 5 of these x tiles. Okay. So we need to create some equal groupings here. So I'm just looking over at our diagram, and the way we have it organized now is the solution is, I mean, it's right in front of us. So not considering the balance analogy, but so x could be worth 4, right? So there's one group of 4 for x. There's another one. Here's a third, here's a fourth, and then here's a fifth. So what that tells us is that in the end, x is equal to positive 4. And if we're unsure about that, we've done this a few times before, we could take that value of x equals 4 and we can bring that back to the original equation. So just let me get rid of these markings here. What we can do is we can take x equals 4 and we can substitute it in for t. Okay, so here, and then of course over here. And following the order of operations, if left side equals right side, you know that x equals 4 must be a solution.